Hello, welcome to video number 4 on Nix programming. We're going to tackle functions today. I don't think we're going to get through all of it. You can find the documentation we're using, which is just what you see on the Nix dev website. It's in the description, and if you have any questions, then you can join the Discord, and I'll be happy to answer those. The idea of this is that if you kind of follow along with me and do the examples with me, hopefully you learn this stuff too. All the previous lessons or little things that I've been working on is also in the description. Alright, so let's get started here. I have the website open. We're looking at functions. And let's look at that. Functions are everywhere in the Nix language and deserve particular attention. A function always takes exactly one argument. Argument and function body are separated by a colon. So notice they say it takes only one argument ever rather than several arguments. So that's very specific. Whenever you find a colon in Nix language code, on its left is the function argument, on its right is the function body. Function arguments are the third way, apart from attribute sets and let expressions, to assign names to values. Alright, yeah. So arguments, when we call a function, we pass in an argument that gets bound to the variable parameter or whatever of the function. So that's another way we assign a name to a value. Values to names. Notably, values are not known in advance. The names are placeholders that are filled when calling a function. Alright, great. Function declarations in the Nix language can appear in different forms. Each of them is explained in the following, and here's an overview. Single argument. Alright, x plus 1. Multiple arguments via nesting. X, y, x plus y. So in this function, we take one argument, x, and it'll add 1 to it. That's its body. Here, it takes two arguments with colons after, and then we use both of them in the x plus y, adding them together. And we have an attribute set argument. Okay, so this is a single argument that is an attribute set. And then we can use the individual I guess, values within the parameter set, in the attribute set, in the function body. So we add the two values in the attribute set. Notice like an attribute set, usually it has like A equals 1, B equals 2, right? Here, since they're placeholders, they just have the name of the attribute set key with default attributes. So this is saying if B wasn't set in the attribute set, then we're just going to default it to 0. With additional attributes allowed. Okay, so that means this would have failed if this attribute set that we passed in actually had a C or something like that. Whereas here it's allowed. And we're only going to look at the A and B. We'll play with all of these in a little bit. We'll see. Named attribute set argument. Args at AB, and then whatever else. A plus B plus args C. Alright, we're going to have to figure that out. I don't have any idea what that means. Functions have no names. We say they are anonymous and call such function a lambda. So these are lambda functions. Example, x colon x plus 1. So let's type that in. We'll use our REPL for that one since it's really easy. Right, that's how it was, right? Yeah. It says lambda. Okay, perfect. The lambda indicates the resulting value is an anonymous function. Alright. As with any other value, functions can be assigned to a name. Alright, so let's do that too. We'll make a thing here. Let f equals, was it x plus 1 that we're doing? Yeah, and I keep forgetting the semicolon at the end. In F. So if I run this now with nix, do you remember what the command is? I think it's nix instantiate minus eval, and then that'll automatically look for default.nix. It returns a lambda, just like we expected, because f is just this function and it has no name. Calling functions, also known as function application. Calling a function with an argument means writing the argument after the function. For example, we have what we had before, but we add a 1 to the end of it. So let's do that. So I just added a 1 to the end of this line. So ideally this means that the 1 is being applied to the function f. So 1 is just passing 1 as a parameter. And we should get 2, right? Because 1 plus 1 is 2. There we go. We see the 2. Example, f. So it looks like we're passing an attribute set because we are trying to access the A inside of the attribute set, and yeah, we're passing an attribute set. So let's write that. So we're passing an attribute set in here, and then we're trying to access the A here. So now let's pass the attribute set where A is equal to 1. Did I write that right? Let's see if this works. Yes. Does that make sense here? We have the X here is a placeholder for an attribute set, and then inside the function body we access the name A, and here A is equal to 1, so it just prints out 1. If we passed in B instead, then this should fail because there is no A. Yeah, so it says attribute A is missing, does not work. But obviously if I change this now to a B, then it will work. There we go. Alright. In the above example, f calls f on a literal attribute set. One can also pass arguments by name. So it's the same function. Then I see. We're just making the parameter a name here. So we'll just call it, I'll call mine P. And we have a B equals 1 here. And instead, now we just call FP, P for parameter. And this should work. Oh, the same mistake I make every single time. And now we have a 1. So this P is just this attribute set, and then we're passing in the P into this function. Alright. Since function and argument are separated by a whitespace, sometimes parentheses are required to achieve the desired result. Alright, so we're basically having this function, and since this returns a function, and then we pass in a parameter, the argument 1, it's going to place the 1 into the function here for x, so it'll be 1 plus 1. So I think we can do this inside of nix REPL. So this was parentheses x plus 1, and then we pass a 1 here, and we get a 2. The reason why we need the parentheses here is because otherwise it wouldn't know that this was the end of the function. This is the function itself, and when you close the parentheses it says this is the function, and now this is something outside the function, so it must be the argument that gets placed into the function. So if we did the same thing and we didn't close the parentheses, or we just didn't have parentheses, then yeah, I guess it's, I don't actually know what this is parsing into, but it's definitely not what we wanted. The expression applies an anonymous function, namely this, to the argument 1. The function has to be written in parentheses to distinguish it from the argument. Pretty much what I said. Example. List elements are also separated by white spaces, therefore the following are different. Alright, let's see. This one here is the function where it adds 1, and then here we have an argument 1. And then we are calling, this is a function, and we're calling it with a as the argument, so this will be the number, this whole thing will be replaced by 2, and it will be inside a list. And here we're doing the same thing except we don't have the parentheses, so this is going to, this f resolves into the function, and this a resolves to the 1. It's not applying the argument, or it's not applying the function to the argument, so it doesn't try to resolve this, because it just looks at these as individual things. So let's try to type that in. I'm not looking at it anymore, and we are going to try to make two versions where we have our normal function where we do x plus 1. And then we have, oh god, I have such a short-term memory. And then we're putting inside of a list. I guess we have an argument, right? Yeah, I think that's what it was. We had an argument. The argument is 1. And then we put this inside of a list. And in this example, we're going to get lambda and 1 because this is just going to resolve into a lambda function. And this is going to resolve to, not p, a. This is going to resolve to 1. So let's go ahead and run an instantiate eval. Yeah, it says code 1. I wonder, does there say code also? No, there says lambda. It probably means the same thing. And now if we put parentheses around it, this is going to say this is a function and it'll apply this argument to the function. So this will be this will become the number 2, this whole thing. So it's a list with one element and the element is 2. Oh, I think it's because I need to do strict. There we go. Because it's lazy evaluation, so it's like, it's some code, I don't know what it is. So here it knows, like, I'm pointing. Here, before I did the strict, it just said, yeah, this is going to be some function that I need to actually run, but I'm not going to actually evaluate it until I need to. So by adding the strict, it says, okay, I'm going to make it evaluate now. And I guess, like, to be fair, we should do the same thing with this and see what it says. Now it'll probably say lambda. Yep, lambda 1. Perfect. Just like here. The first example reads, apply f to a and put the result in a list. Yeah, because it has parentheses in it. The second example reads, put f in the list, this is just this, and put a in the list. So now we have two elements, the lambda function and the 1. How long have we been doing this? 15 minutes. Should we do curried functions? Yeah, we can do curried functions. So curried functions is basically, I learned this when I was looking at Haskell. We should do a series on Haskell soon. It's basically saying, like, how do we get, like, something that looks like multiple arguments by just passing one argument at a time. So we're gonna get to multiple arguments, and it's also known as curried functions. Nix functions take exactly one argument. Multiple arguments can be handled by nesting functions. Such a nested function can be used like a function that takes multiple arguments but offers additional flexibility. So here's kind of like how we write it. X, y, so we have two arguments or that we can pass in. And then here's the body of the function xy, and it's obviously just going to be a lambda. And we can write this in Nix REPL also. X plus y, I think that was it, right? Yeah. Maybe I should do the, was it P to make it strict evaluation? I think so. Let's see if I have any memory. Yeah, okay. Same thing, it's a lambda function. And it's saying this is the same thing as saying we have a function that takes one variable, x, right? And the body of the function is another function that takes one parameter, y, and then we pass, the body of it is x plus y. So if we look at the steps of what's actually happening here, I'll just write it here, x colon y colon x plus y, right? The very first step is we just kind of like try to separate it so it's easier to read. This means the same thing. Forget like these ligature things here. So it's saying that xy is just syntax for saying it's a function that takes one argument, and the body of the function is another function, right? So if we do something like, if we're trying to call where x is 1 and y is 2, then it looks a little bit like we pass two parameters, right? So now when we try to do it, it's going to say x is actually 1. So what's that going to do? It's going to return y is 1 plus y, right? And now the second parameter is 2, right? So then now 2 basically becomes 1 plus 2. So you can see how that resolves. These are just nested functions. If there's any questions on that, ask in Discord or comments. Curried functions are a little bit hard to grasp at first, but they do offer some benefits, like it said, and I'm sure we're going to talk about that in a minute. Alright, so this function takes one argument and returns the function y x plus y as the body, with x set to the value of that argument. Right, so I guess I can type this. We're just going to pass one argument at first. And x plus y, right? And then we just pass one argument at first. We run this, and it returns us a function, which makes perfect sense because remember, it's supposed to pass us the function y, and it takes in 1 plus y, right? That's the function that we ended up with. Applying the function results from f1 to another argument yields the inner body x plus y with x set to 1 and y set to the other argument, which can now be fully evaluated. f1, 2. So let's do that. Three. I have no idea how many people I've lost here. So remember that maybe this can show it a little bit better. I think this should still work, right? Let's see. Yeah, it still works. So these are syntactically equivalent. Now, if I write f2, let's call this f1. And f2 is just equal to f1. but we pass in the value 1. So what does this give us? This will give us the function that is where x is equal to 1. So now this will return us a function that takes in a y, and the x is now a 1, right? So it looks like this, right? 1 plus y. And now I should be able to call f2 2. You see? So this is now a function that takes 1 argument, and we're going to pass it a 2. And that goes into the y, so it should return us 3 because 1 plus 2 is 3. Alright, same problem I always make. 3. If that makes no sense, don't worry about it. You can always just say, it doesn't matter. Just whenever you see this format where you have x, y, just know that it is a curried function, or it's just a function that takes 2 parameters, x and y. Then you'll be fine. Alright. Did we go in here? I think so. Applying the function, yeah, I think we maybe already said this. We already did all this. So hopefully that makes sense. We're just, yeah, I think we're out of time. Attribute set argument. Oh, and then we have default our value. So yeah, let's do this next time. We'll continue at attribute set arguments next time. Leave a comment if that was confusing or if you understood. Do you want it to go faster or slower? Yeah, do like and subscribe if you enjoyed this. Thank you. Bye.